Hi everybody, this is Chandan, and today we're going to discuss about the special theory of relativity. So this will be an introduction class for you, and before proceeding to special theory of relativity, actually I want to introduce in a different way. So in 1880s, actually up to 1880s, Newtonian physics was the considered to be the most successful model to describe nature, and in 1883, Arnmast published a paper, a book, Science of Mechanics, where he actually did some difference with the conventional Newtonian physics. So, first in Newtonian physics, the idea of space and time is like you measure the space with a yardstick or a meter stick, a unit, and time is to be measured through clocks. But Arnmast actually gave an idea about how the approach will be. The Arnmast is a German physicist, and in 1883 he published a book which is called the Science of Mechanics. And he criticized the idea of Newtonian idea of space and time. So what he actually suggested that physical concepts to be defined in terms of observable. So physical concepts defined in terms of observable. So, but the real difficulties actually arises when the Maxwell's EMT is but the real difficulties arises with the Maxwell electromagnetic theory. Maxwell electromagnetic theory is a success story of the classical physics. So so it was obvious that any observation, any experiment which is not coherent with the results predicted by the Maxwell EMT electromagnetic theory will be considered as a nonsense. So actually the Albert A. Michelson conceived an experiment perhaps in 1887, which is now known as Michelson and Morley experiment. And at that time Michelson did the experiment, but according to Michelson it was a flop because it is not coherent with the well established Maxwell electromagnetic theory. So it was obvious that time that if a well established theory reject an observation performed by an experiment, then the physicist might think that okay, there should be any mistake or fault with the experiment itself. But then year passed. Then in in 1906, one of the most famous scientists ever, Albert Einstein, published a paper on special theory of relativity. And in that paper, actually, he managed to define the space and time in a different aspect what conventional Newtonian physics actually had tried to define those space and times. So it has actually shaken the very foundation of the success, the foundation of Newtonian idea of space time. So and the interesting thing is that in 1906, actually Einstein was not aware about the experiment performed in 1887 by Michelson-Morley, because at that time Michelson thought it was a flop one, and the experimental data and everything actually thrown into the dustbin. So it was dumped. But after the discovery of Einstein, after the establishment of special theory of relativity, actually the Michelson-Morley experiment defined a new approach to the experimental approach to the special theory of relativity, and was immensely important at that time after the discovery of 1906 to understand the consequences of special theory of relativity. And after that, it is customary that every lecture of special theory of relativity should begin with this very famous Michelson-Morley experiment, because this is the real departure for a physicist to easy understanding of the special theory of relativity. So in next video we will be studying in detail about Michelson-Morley experiment and the approach of R mass that the physical concept should